Hi, my name is Renee Obringer and I am a PhD student at Purdue University in the Division of Environmental and Ecological Engineering. My research focuses on evaluating urban water availability using statistical learning techniques. Today I'm going to talk to you about my current research project on predicting the climate-sensitive portion of the residential water electricity demand nexus. In many places around the United States, and especially in the Midwest where I'm from, the fact that water is always there when you turn on the tap is taken for granted. However, with unprecedented urban population growth occurring at the same time as climate change, those water resources that we often take for granted will be put under an immense amount of stress. In this sense, urban water availability is a major issue for ensuring future urban resilience. One way cities can prepare for this stress is to increase their water supply. However, these supply-side projects are expensive and often not feasible. In these situations, cities must turn to water use management. The idea is that if a city uses less water, the limited water supply will last longer. Unfortunately, plans to decrease water use in the city often backfire and lead to higher overall water use. One study, for example, showed that when water-intensive landscaping was replaced with drought-resistant landscaping, the direct water use dropped, as expected. However, since drought-tolerant plants do not release as much water through transpiration, the overall evaporation decreased, which led to an increase in local temperature. This change in microclimate led to increased electricity use, which ultimately led to increased water use over the entire study area. This interconnectivity is known as the water-energy nexus. In my research, I employ an algorithm known as multivariate tree boosting to predict the water and electricity use as a pair of interdependent response variables. This algorithm is a decision tree-based method that uses the meta-algorithm boosting to build a robust and accurate multivariate model. Boosting is an iterative algorithm where at each iteration a prediction is made, and any variables that were poorly predicted are given more weight in the next iteration so that their prediction improves. After all the iterations are completed, the results are aggregated into a final model. In this project, I used several climate variables to predict the water and electricity use, including dry bulb temperature, dew point temperature, relative humidity, wind speed, and the El Niño Southern Oscillation Index. The El Niño is a climatic phenomenon that starts as a warming in the South Pacific and leads to changes in climate throughout North America. The study area included 6 Midwestern cities: Minneapolis, Minnesota, Madison, Wisconsin, Chicago, Illinois, Indianapolis, Indiana, Columbus, Ohio, and Cleveland, Ohio. Our results show that water use is slightly more climate sensitive than electricity use after the seasonality was removed from the time series. This can be seen in these plots where water use is on the left and electricity use is on the right. Each city is plotted with a black 45-degree line for reference. These plots demonstrate that water was better predicted by the climate variables and therefore more sensitive to climate than electricity use. This is further demonstrated by the R-squared shown in the table, where water use is much higher than electricity use in most of the cities. Additionally, our results demonstrate the importance of El Niño strength for predicting water use as well as the water-electricity nexus. Since the El Niño is a well-documented process and can usually be predicted months in advance, this result can be applied to cities that are trying to get a rough estimate of next year's water use. In other words, if NOAA is predicting a strong El Niño, these cities can expect to see higher water use than usual. The next step in the project is to use future climate variables from downscale global circulation models to project the water-electricity demand nexus into the future. The results of this work will ultimately be combined with water supply data to assess the overall state of water availability in select cities. Thank you for listening to my talk, and if you have any questions, please feel free to email me. Thank you.